Right. In this last lesson on the trigonometry, what we are doing is using our rules of trigonometry to help with complicated integration problems. So I'll give you some examples. For example, take the headphone out. Really, really nice when you have it in class. Alright? It feels like, whatever. Right, so integrate, for example, 6 integrate cos x sine 4x dx. That's 6 integrate sine 4x cos x. Not that it matters too much. So we don't want to use integration by parts or substitution. What we can do is we can say sine a plus b is sine a cos b minus sine b cos a, and sine a minus b is sine a cos b plus sine b cos a, and by adding I can get 2 sine a cos b should equal sine a plus b plus sine a minus b. Do I have 2 sine a cos b in my integration up here? Is this the same thing as this?
Yes.
Nearly, except for...
6.
Yeah, I need the 2. Easy peasy. I'll just change 6 into 2 multiplied by 3. Now we have 2 sine a cos b. 2 sine a cos b. So we know that this can be rewritten as sine a plus b plus sine a minus b, where the a is 4x and the b is x. Now this is much easier to do because this will be 3 minus cos 5x over 5 minus cos 3x over 3 plus c, or it's probably written in the book as minus 3/5 cos 5x minus cos 3x plus c. Yes, it is. Okay, next. Yep.
Can you scroll down?
You change
Change to what now?
4x into 5.
4x plus x.
But you can't plus them.
Huh? I know I can't. I know I can't add them. But the formula is 2 sine a cos b is sine a plus b plus sine a minus b.
See, we can use this way in all problems.
Oh, okay.
All problems that have an integration of sine multiplied by cos. Okay, continue.
Give me 20 seconds.
20 seconds. Do you like my new phone I bought?
You bought this from you?
Well, can't buy it new, they don't make it anymore.
Good.
It's 8 years old.
How much is
Got it €30. Difficult to find. But I
what
like
happened
it.
to last
I still have it. But I wanted to get something with a camera.
With what?
Hmm?
With what? Something with what?
A camera.
This has a camera.
Yeah.
5 megapixels.
Yeah. No, actually, sorry, 8 megapixels. Actually, yeah. 8 megapixels. At least, I think. Maybe even more, actually.
display?
Yeah. HD display. Well, of course.
Retina display.
Yeah. Solid state drive for some reason.
Front camera as well.
Front and back and side. And infrared camera too. Let's see what else. 2 gig RAM. Graphics card as well for gaming.
Smart pay.
Smart pay. Smart pay, of course, absolutely. Doesn't everybody's phone have smart pay? And also a very special feature, holographic technology. Check the little hologram out. Yeah, a lot of people don't have this yet. No, I got it because I wanted something a little bit better than my phone, but I wanted to be flip. So I don't like smart. And I wanted a camera. And what I also like about this phone is I like that it has the screen on the front. So I can see who's calling and then you answer by just, it's a much more natural way to be using a phone. Like I can see who's calling and I can either open it or not open it,
You don't want to answer.
So you can use this,
And do what?
Like this.
Yeah, but this isn't like swiping is not an intuitive thing to answer or reject a call, So like if someone's coming and you're like, oh, I don't want to talk to them, swipe. Oh no, I swiped the wrong way. How do I hang up?
Not
And
that.
they'll hear you. Oh, this happens to
Okay,
people.
no,
This
no.
happens to people like, oh, I don't want
Maybe
to
to
talk to.
some people.
No. Happens to a
People
lot of
don't
people.
want to
I don't want to talk to somebody. Swipe.
No, that's good.
And then you put the phone in. I can't stand that Egypt KJ. And is the call connected?
There was one phone that, LG's phone. If you're calling this someone's same phone, with when he just it's ringing, you can answer, you can listen what's people talking around them.
Okay, Steven,
Interesting.
Yeah.
someone called you and you don't want to answer.
Then I don't answer.
Yeah, but it's still running. So it's still running.
I'll go to voicemail.
Voicemail. You cannot make it silent. This is the
True,
problem.
I can't. But I don't mind about that. I don't care about that.
Yeah, but like for example, if you're sitting somewhere in a meeting maybe.
If it's important, I put my phone on silent.
Yeah.
The thing is to remember to do that. Right. Next now.
You need to go to settings, there's one key actually, press it to go silent, right?
I can set silent on a timer. So I can go to silent and set it to be on silent mode for like 2 hours, so then I don't forget to turn it back after the meeting. Can your smartphone do that?
Yes.
Can it?
Yes.
Yeah, you probably have to download an app to do it, and then the app doesn't install, and then it has a malware on it. Yeah. Behold the
No, there's
future.
settings
Yeah.
there.
Right. Let's have a look now. The next one here. So, well, before I do an example,
Which one you doing?
no, I need to give you a formula before I do it. So, let's say I have something like y equals sine inverse x, and I would like the derivative here. Well, I can't. There's no rule for this. I need to find a rule. So I'll use implicit. I'll put sine on both sides, and I get this. Let's use implicit derivatives. What's the derivative of sine y?
Minus
Cos y, positive cos y, times,
Y is positive.
because it is from semester 1, the derivative of sine is cos. Cos y times, thank you, and derivative of x, 1. So dy dx equals 1 over cos y. Now you can draw this triangle.
Wait. derivative of sine. Okay, yes, yes.
You can draw this triangle. The angle is y. The opposite is x. The hypotenuse is, because this is like x over 1. The hypotenuse is
Square root of
1.
minus.
No, just 1. What's the definition of sine? What over what?
X over
Opposite over.
Hypothesis.
Opposite
Opposite
over
over hypotenuse.
hypotenuse. So this is the opposite, this is the hypotenuse. Yes, and this is square root 1 minus x squared. So what does cos y equal?
1 minus.
Root 1 minus x squared.
Over 1.
So it's just root 1 minus x squared. So this is 1 over root 1 minus x squared. So the derivative of sine inverse x is 1 over root 1 minus x squared. So therefore, is this how we end? Yeah, it is. This is the end of us. 1 over root 1 minus x squared dx integrated should be sine inverse x plus c. So this is a new formula we have for this lesson as well. It is in the formula book. This is the proof of it. The proof I've seen on the exam, because you can get trigonometry proofs in the exam, including proofs of trigonometry in calculus. So this is a possible exam question, this proof, exam proof possibly. Okay. Now that we have this rule, we can do an example that's like it.
Which one you
I'll do 2a, just basic example. Can I go down?
Yes.
Yeah. So here we would like to integrate 1 over root 16 minus x squared. So there's a substitution you should make. This should remind you of the lesson we did on integrating simple rational functions. There's a substitution to make here for u. What do you think it is? Nope.
Square root of
Nope.
square of
Go on.
square of the first over the square root of the second.
Almost. Now for the lesson we did previously that was the case. But to be a bit more accurate, we said square root the first over the second, but maybe to be more accurate we should say square root of the x squared part over the non-x squared part. In this one it's written backwards, the x squared's at the back. So here it'd be square root of the second part over the first one. So that would be u equals x over 4. So what does du dx equal? What does du dx equal? What does du dx equal? Here. I'm only giving you 10 more seconds on this and I want an answer.
4x minus.
No?
1 over.
Thank you. 1 over 4. So that means dx is 4 du. And also from here I can say 4u equals x. Let's put these back into the equation, the expression. 1 over root 16 minus x squared, which is 4u squared, and du, dx, which is 4 du. So this would be 4 du over root 16 minus 16u squared. So this is 4 over root 16 1 minus u squared du. Now what's the square root of 16? 4. So in fact that 4 cancels the 16 under the root. So you have integration of 1 over 1 minus u squared du. What does that equal though? What does this equal?
Sine inverse of
U. So that is sine inverse x over 4 plus 6 is the
So
answer.
you would zoom out.
Like here? And then let me scoot it over.
Is that 4U or 44? 4U, right?
It has to be 4 years, it's not 44 here.
Yeah, I know. That looks like.
What looks like 44? In the circle?
Yeah.
In the
The
circle?
bracket, the bracket, the
Alright.
bracket.
Bracket. Here?
Up,
Here?
up, yep.
Fair enough. It does kind of look like 44. It's for you though. Right. Next example. So.
26.
Oh, come on, Fahad. Pick up the speed.
I'd like to work on next week.
Yes. Beat that high score.
An exam maybe.
That was 2A as an example. Let me do 2I.
You can do
Now,
2I.
so we want to integrate 1 over square root minus 65 plus 18x minus x squared dx.
Minus 65
Okay? So there is no first or second here.
No.
What should I do here? That's it. But before I do that, KJ, I'll take a minus out. So I'll have x squared minus 18x plus 65. So now I'll complete the square. And I'll get minus bracket bracket x minus 9 bracket squared. So what's that? 81, 65, 16 plus 16. That's the completed square, I think. 81. No, I need a
65.
minus 16? Yeah, I need a minus 16.
Minus.
Minus 16. Yeah, that's it.
65 minus 81.
Yeah. Okay, so now we'll put the minus back in. Root 16 minus x minus 9 squared. Yeah. So now we make a substitution. What do we let u equal to? Root
X minus 9
x minus 9
over
squared over 16. So u would equal x minus 9 over 4. What does du dx equal? One over 4. So that means 4 du equals dx. Also, I can rearrange this. Look here. I'll put it up the top here. I could say 4u equals x minus 9. Now that's useful because what have I got here? X minus 9. So I know that x minus 9 is 4u. And I also know that dx is 4 du. So if I sub this in, I get 1 over root 16 minus 4u squared 4 du. Now, we've actually done literally that problem a moment ago. What happened was the 16 was taken out, and then the 16 with the root makes 4, and the 4 cancels the 4 on the top. Look at this, look at this, look at this that you just wrote. It is 100% the same
Right now.
as this here. So I can jump straight to knowing that the answer here is sine inverse u plus c. So that's sine inverse x minus 9 over 4 plus c.
Is the same answer?
Well, not the same answer, but the same last few steps. Okay, let's have a look now at 3a. No formula required, just a technique.
3?
3a. Right, can I go down? Yep. So we would like to integrate, oh by the way, all of these I've seen on the exam many times. Very common exam question. A and B. Yeah, A and B. Now, this here, not quite what we had in part question 2. In question 2, in fact 2a was 1 over 16 minus x squared, wasn't it? 1 over root 16 minus x squared. This is root 16 minus x squared. So it's similar but different enough that we can't do it the same way. So how do we do this one? Well, what we do is we draw a triangle. And we make the hypotenuse 4. All will become clear in a moment. This is where you have to be patient, and then the clouds will part and the answer will fall before you. Okay? Or, well, maybe not as dramatic as that. Okay. Now let me think. We have to call one of these x. So if I call that one x, then this one would be the root, and the root here would be cos. Do I want cos theta? Let me just think. I have to call one of these x, and it doesn't matter actually which one I call x. Just give me 30 seconds to remember which one is the x. 30 seconds of peace, please. Thank you. Okay, so if I call this one the x, this one would be root 16 minus x squared. That would mean root 16 minus x squared over 4. That is adjacent, that is cos theta. If this is the x, then sine theta. This is x. Okay, don't write it down just yet in case I made the wrong choice. I won't scroll down until you're ready to catch up. But I think the way I do these ones, if I remember, is I call the opposite side x, which confuses me because I feel like I should call this one x, but I think this one is x. So if I make a right angle triangle with the hypotenuse as 4 and the opposite as x, how big would this side be? Square root 16 minus x squared. No, don't do that. It's Pythagoras.
No.
You know this. What's 4 squared? 16. Okay, so don't make faces like that. And this angle I'll call theta. So what is the sine of theta? X 4. And the cos of theta? Root 16 minus x squared over 4. Yeah? So if I look at this, it's almost like the cos of theta, except what am I missing? Divide by 4. So I'll just put this over 4, and I'll put a 4 here. So I've changed this into 4 integrate No, don't write just yet in case this goes wrong. Cos theta dx. Now what's the problem here?
Another theta.
No, that's not really the problem. What's the problem with this integration?
There's no problem.
No, there is a big problem. A
You can't
huge
solve
problem.
something.
Oh, there's no X.
Thank you, Tack, and go ahead.
Change,
You have theta and x. This is bad. So this one needs to be changed. So if I look at this, and if I bring the 4 up to the left to have it as 4 sine theta equals x, then what does dx d theta equal? This is x equals 4 sine theta. So what is dx d theta? What's the derivative of x? What's the derivative of 4 sine? 4 cos theta. Hey, 4 cos. That kind of looks good, doesn't it? Because if I bring the d theta up to the right, I get dx equals 4 cos theta d theta. Do I have 4 cos theta d theta? I can replace dx with 4 cos theta d theta. So this dx, I replace it. So I get 4 cos theta, 4 cos theta d theta. So this will be 16 integrate cos theta d theta. Have I seen a problem like this before? I have. It was literally the first, well, not literally, but it was the first problem I did. Except the only difference was my first problem was sine multiplied by cos, but this is cos multiplied by cos. It's the same method, except I shouldn't use sine a plus b, I should use cos a plus b. Okay, so I'll pause there for you to write this much down. So, wait. This is important because I had trouble remembering it, which means you'll definitely have trouble remembering it here. When you draw the triangle, the x does not go on the x-axis. You draw it, this is how we can remember, we draw it opposite the theta, not on the x-axis, actually on the y-axis. I always feel like I should put the x down below. So when you draw the triangle, put the x opposite the theta. So this is a bit like rough work on the side, so I'll put a line down the middle to distinguish it.
You can move the 4 from there to the front of the
Yeah, this 4 I brought up because originally it was 4 sine theta. Originally, well, you can see it here, sine theta equals x over 4. So I brought the 4 up and made x equals 4 sine theta.
Okay, but 16 here come from the same.
This 16?
No, the 16 there on the left side.
Oh, this?
Yes.
4 by 4.
Okay, 4.
Continue? So, if I go down a little bit, you know that cos A plus B, what does that equal? Cos A, cos B, actually, so I'll start off with cos A minus B, so I can get the plus cos A, cos B, plus sine A, sine B. And what about cos A plus B? Well, that would be cos A, cos B, minus sine A, sine B. If I add these together, on the right I'll get 2 cos A, cos B, and on the left I'll get cos A minus B plus cos A plus B. Sorry, you can't see that, but here this one is the minus and this one here is the plus. So this is cos A minus B and this is cos A plus B. I mean, we've done this a few times already.
Why did you apply this rule?
I'm trying to get a cos because that's what I have here. Do I have 2 cos A cos B?
But you know,
Yes.
Yeah?
theta is the
It
same
It
value.
doesn't matter. Doesn't matter.
Doesn't matter.
No. Do I have 2 cos A cos B?
Not yet.
Nearly. What do I need to do?
8,
Yeah, change 16 into
8.
8 multiplied by 2. So now, look, I have 2 cos A cos B. So I can use my rule on the right to change this into 8, integrate. Okay, so what would be cos A minus B here?
Theta minus
Theta minus theta, which is?
0.
So that's cos 0. Plus cos A plus B, what would that be? Cos
Plus
mhm,
theta square? No, 2 theta.
2 theta. What's cos 0?
1 minus
1 plus cos 2 theta d theta. So if I integrate, this would be 8, 1 plus sine 2 theta over 2 plus c. Is that finished? No. Why not? I'll give you a minute to catch up.
Could you go a bit? I can't see.
Oh, you want me to scroll down so you can get the bottom, is it?
Oh, yes.
Yeah?
Yes.
Is this finished, the integration?
No.
Why not?
Sure.
There's 8.
Oh no, there ain't. There ain't nothing wrong with the 8 in the front.
Now simplify.
No, it's quite simple actually.
Sine 30.
What's wrong with that? What's wrong with this?
You can simplify it for
No, it's already quite simple. The problem is it's in theta, and the question was in x. That's right, if we go back to the question, I asked you to integrate root 16 minus x squared, and your answer should be in x. Is my answer in x?
Yeah.
No, it's in theta, so let's fix that. What is the rule for sine 2 theta? 2 sine theta cos theta over 2 plus c. Now what happens here? Well, the 2's cancel, don't they?
Yes.
So I'm left with 8 bracket 1 plus sine theta cos theta plus c. Or if you want, that's 8 plus 8 sine theta cos theta plus c. Although we can put this 8 and the c together, and we get 8 sine theta cos theta plus big C. But that's still not finished. But at least it's a little bit easier to finish now, because if I go back to my triangle, this was theta. How big was this side? This side?
4.
4. This side?
X.
X. And this side?
Root
square root 16 minus x squared. So what is the sine of theta here?
X over 4.
And the
Sine.
cos of theta?
The square root 16 minus square root of 4.
Or 4. Let's see. 4 goes into 8 twice. 2 goes into 2 once, and 2 goes into 4 twice. So this would be a half x root 16 minus x squared plus c.
Is that also right?
Who knows?
Is it right the 8? Oh, there.
It is.
No. 3a.
Oh! Yes, I can easily fix it though. Nobody spotted my mistake right here. If I integrate 1, what do I get?
0.
No,
X.
theta. So I've just missed a theta here.
Or integrate.
Yeah, theta. So I've just missed a 8 theta in my answer. So just put in a, where there's 8, just put in 8 theta. Okay, so what is theta though? How can I get theta from this triangle?
Sine inverse.
Yeah, what does it go ahead, KJ?
Sine inverse X over 4.
No, it matches up for Had.
Stephen,
Yeah.
8 theta plus sine
2 theta over 2, yeah.
How did you change it to 2 sine theta cos theta?
Oh, Fahad!
It's correct.
Sine. Oh, sorry. Let me take that back, right? Oh, Karar! We gave the formula, was it last week or this week? Last week. Sine 2a is 2 sine a cos a. This is the lesson on double angles, which is on page 54. I know it's difficult. That's why you need to do homework and revision.
No, I mean this question.
Oh, it is difficult too.
That's why you need to do homework.
Yep.
Exam question?
Yep. I've seen this once in the exam, or twice.
You never know.
You never
It
know.
could be your guess.
You never know what you get. Let's have a look actually. Let's see. What? Okay. Where did I did see it. Okay, let's have a look at this here. I can't remember where I saw it. I did see it in one of the exams or something like it. What year was that? I just went into 2010. Maybe that's too far back. Ah. Oh. Okay, it's not quite the same, but it's more of a lesson on the substitution, so it's not quite that one. Here, look, here's a proof one. What we just did, prove that tan plus cotan is 2 cosec 2 theta.
I know.
Mhm. Oh look, and here's what we did this week as well. This is what we'll do tomorrow, Tekken. The further trigonometry. And this is also, I don't think this will be a trig. But if I look at section A,
This is from last year.
no, this is 20, I can't remember, a few years ago. Quotient rule, Newton-Raphson, differential equations, derivatives, further trig, vectors, further trig, substitution, statistics, implicit, you should be able to do that, partial fractions, vectors, no. Right, what year was, let's go 2013. Right, that's the answers, don't want that. Okay, now again, look, this one here is a trig equation, which we just did recently. There we go, there's a integration there, with trig integration. Can't quite find the, maybe I have to go really far back to the beginning. Again, okay, this is a trig integration. They give you the substitution here. Differential equation, that. Trig, vectors. No, I can't find it right now. I've seen a question like this in the exam. That's why I have it in here. But I think they kind of more prefer questions like number 1 and 2. But I have seen it anyways in the exam. Right, okay, so the situation is when we come tomorrow, please remember your laptop. Tomorrow, please remember your laptop. In the in the first class, well, which do you prefer? Do you want to work on your assignment in the first class or the second class?
One of the customers.
No, we've two math classes. Oh, so which is it?
The second.
Second, you want to, okay. So you can work on your assignment in the second class. In the first class we'll do a tutorial. We'll do some more trig problems. So Tekken already has a couple of questions from page 58, which we'll do. So if you have other questions, please find them for tomorrow. Trig is quite a big chapter, so there might be a few questions. That's of course if you're doing your homework and you manage to find questions. Do your headphones go back into your ear? Take them out, thank you. I'll give you your maths test and physics test after Easter. I don't know what difference it will make. I don't think it will make much of a difference. People aren't studying so much. Although we'll get, some people are, but not everybody.
Yes.
Sorry, not most people. Alright. Put the light on please, we'll go.